All right, we're going to go ahead and get started. Welcome to our Managing Research Code with Git and GitHub workshop today as part of our Data and Donuts Fall 2024 series. I'm Michael Shensky. I'm the Head of Research Data Services for the UT Libraries. I'm joined by my colleague, Ian Goodale. I'll go ahead and turn it over to him to introduce himself.
Yep. Hi, everyone. Thank you for attending. My name is Ian Goodale. I'm the European Studies Librarian for the UT Libraries.
All right. Yeah, we're glad to have you with us this afternoon. So we're going to be getting into our topic today. Before we do that, I just want to go over some logistics, make a few announcements. You can turn on automated transcription with Zoom. If you are having any issues, you should be able to toggle that closed captioning button at the bottom of your screen. Let me know in the chat if you have any issues there. Feel free to ask questions and add comments in the chat. We will be able to allow folks to unmute at the end, but during the slides that we'll be going through and the demo that we'll be doing here from 12 to 1 o'clock, please just go ahead and put your questions in the chat for that portion. And then, like I said, we can unmute if it's easier for you to ask a question out loud once we get to the end of our session past 1 p.m., where we'll have time for questions until about 1:15. The workshop is being recorded, so please keep that in mind. If you do plan to ask any questions, that might be included in the recording. And want to let you know that our recorded workshop will be posted on our Data and Donuts LibGuide at the URL listed there, along with our slides and other materials that we can share out at the end of the session. So probably later this afternoon, those things will go up on the Data and Donuts LibGuide. All right, and just as a reminder where we're at in our Data and Donuts schedule here during the fall semester, we are here on October 11th, Managing Research Code with Git and GitHub. We have one more session coming up after this one that will take place on October 25th, Intro to R for Data Management, and that one is going to be held in a hybrid format, so it will be in person in our Perry Castaneda Library Scholars Lab if you want to come join us and have some donuts. There will be donuts on hand for you to partake in. We'll also be streaming that on Zoom. So if you're not able to make it in person, don't worry. You can watch virtually on Zoom, and you can also watch the recording afterwards, since we will be recording it as well. All right. So with those logistics out of the way, I'm going to go ahead and turn things over to Ian. He's going to walk you through the first part of our workshop today.
Yep. Thank you. I'll go ahead and share my screen in a second. See if I can get that. There we go. So I'm going to go ahead and share my entire screen. I'll go into slideshow mode, but we are going to be jumping back and forth kind of between the browser and the command line a little bit later in the practical portion of the workshop. So let's see. I'll go ahead, share that now. Go into slideshow. And before we get into that, I'll just kind of give a brief overview of my portion of the workshop. So first, we're going to talk through a little bit about what GitHub is, how you can use it. We'll get our accounts created so we can go in and start actually creating repositories on the site. We're also going to download something called GitHub Desktop. That will allow you to actually get into the command line tool that I will be walking you through in this first portion of the workshop. Later on in the second half, Michael will be walking you through a graphical user interface that kind of goes on top of that command line tool. So at this point in the workshop, before we kind of get into what Git and GitHub are and how to use them, let's take a couple minutes and just go ahead and create our GitHub account if you don't have one already. You can follow this link, github.com, and I have a window up where I can show you what that looks like as well. There we go. So this is what it'll look like when you go there. If you just click sign up in this top right over here, it'll walk you through the process of creating that account. Use whatever email you'd like, just set up a password and it should be pretty quick. After you've done that, you can go to this link here that I put in the slides, this desktop.github.com, and that will allow you to download the GitHub Desktop app, which will allow us to get into the kind of practical command line portion that I'll walk through in a little bit as well. So I'm just going to give everyone a couple minutes to go through and do that. And if anyone runs into any issues, please drop a note in the chat. I'll be happy to help troubleshoot as much as we can. So yeah, I'll just take a couple minutes, let everyone get started with that. And then once that time has passed, I'll go in and start talking through the other slides. All right, I'm not seeing any issues in chat. It's okay if you're still working on that, but I think just in the interest of time, it's been a couple minutes. You can keep going through and getting things installed or getting your account set up if you're still working on that. But while you do that, I'm just going to start talking through the other slides as well, so we don't end up getting too rushed at the end as we go through the other content. So this is just kind of a brief introduction to what Git is. Um, this link here, if you're installing GitHub Desktop, you don't have to worry about. But if for some reason you did prefer to use the command line tool Git, which is what I'll be going over in a second, without that graphical user interface on top of it, you could always uninstall GitHub Desktop and use this link instead. This will only install Git, which is really the command line tool that GitHub Desktop kind of goes on top of. It allows you to interact with it and do exactly the same commands that we'll be doing in the command line, but just, gives you kind of a graphical interface to make it a little bit more user friendly, especially if you don't prefer to type in the command prompt. Many people do prefer the command prompt, which is why we're covering it in this workshop. It can be a little bit more streamlined, a little bit faster, especially if you're already running code from the command prompt, as you're working on a project. But both options are completely, good and acceptable. So hopefully you all feel confident after this workshop. It's kind of trying both out and seeing what works for you. Um, so Git basically is a distributed version control system, which means that it allows you to control the project you're working on, typically something that is code related. Um, Control the versioning, collaborate very easily, work with other people, or even if you're just working independently, lets you keep versions sort of living in sort at a chain of changes, basically. So a simple way to explain it is, let's say you create a simple code file, everything's working great. You push that to your repository and keep it tracked in Git. Later on, you make a change and something breaks, the code suddenly stops working. You don't really know what happened. Maybe you've made a lot of changes in the meantime. You're not quite sure where something went wrong. Git allows you to very easily roll back to that original version and kind of undo the changes and go back to that first file. So allows you to manage a lot of issues that can come up with breaking changes in code in that way. As I mentioned before, it's great for collaboration as well. So if you're working with other people on a project, this allows you to kind of both work on your own versions on your local machines and then push them to a central repository where those changes can be tracked. Um, you could have someone, a collaborator, for example, working on their own version of the code, make changes, and then you can actually pull those changes onto your local machine as well. So you don't have to deal with any sort of messy file management, passing files back and forth, trying to make sure that you're working on the most current or the most updated file and so on. It really just kind of centralizes and simplifies a lot of that file management. It's completely free and open source. So you should not be charged for it at any time, and the code is completely open. Community members can submit feedback, find bugs, things like that, which makes it very reliable and very vibrant community around the technology. It's cross-platform compatible, so it works totally fine on whatever OS you're running. Windows, Mac, Linux, whatever you're working with. And then you can run it via terminal or command prompt if you're not using that graphical user interface. So I'm going to go through a few essential Git commands. We are going to go over most of these in the Git tutorial portion where we're actually getting to the command line. So you don't have to worry too much about about digesting the meaning of these as I go through them, since we'll kind of go through it practically as well, which can help kind of teach what these actually mean. But init is initializing a new repository. So this is what a repository would look like on the GitHub website. You'll see they have all of their code, all their folders organized. Um, when you do git init on your local machine, you're essentially creating a local version of a repository like this on your computer. And you're having Git track all of the changes that you make as you go through. So tracking new files, tracking changes to files, things like that. Clone is what it sounds like. It is cloning a repository that lives somewhere else. So in this case, you can see if you go to the GitHub repository of matplotlib, which is a popular Python library, and you click the code button on GitHub, you'll get these cloning URLs or different ways to clone the repository. So if you do git clone and then you copy this URL in, that will download this entire repository to your computer, and then Git will, track that repository as well. So you can make changes to it locally. You can do other Git commands to like pull changes that have been made in the meantime, and so on. Git commit is just creating a tracked change in that repository on your local machine. So let's say we downloaded matplotlib in this way through git clone, and we wanted to make a local change to the library. We wanted to change one of the functions in this folder to serve something, on our project or whatever that we just want to keep local. We could go ahead and make that change in the code, and then if we git commit that code, it will change that library on our local machine. So it won't affect the remote repository at all, but it will go ahead and track that change and make that change in our local code. Git push is where you actually take those commits that you made locally and you put them up into the remote repository. In this case, it would be the one on github.com, so that those can become public and other people can see those changes as well. Of course, you can only push to GitHub repositories that you have editing access to. So typically, these would be ones that you own in your own account, but you can be, invited as a contributor or an editor of repositories as well. And git pull finally is the command that takes any changes that have been made to that remote repository and brings them down onto your local machine. So let's say we had downloaded this matplotlib a long time ago. We had cloned it 3 months ago. Since then, they've made a lot of updates. If we run git pull within the folder that we have this matplotlib downloaded to, it will go ahead and grab those remote updates and update the copy of the repository on our local computer as well. So talked about GitHub a little bit, but I'll just go through it again. GitHub is a website that sort of runs on top of Git, as you could tell. It's a great platform for backing up, versioning, collaborating on, and sharing code. Um, it's a very vibrant community. A lot of open source enthusiasts use it. It's a great tool for researchers who want to make their work transparent and replicable, and also just kind of get it out there and maybe get, a new audience on your work that maybe wouldn't encounter what you were working on if you didn't put it on GitHub. If you had only put it in, an academic repository, for example, you might just not get as broad of an audience as you might get on GitHub. There are two GitHub websites that we'd like to highlight here. So github.com is the kind of standard public GitHub open to everybody. Anybody can create an account, as you all did at the beginning of the workshop. We also have a utexas.edu enterprise version of GitHub, which is only for faculty and staff. I'll show you what this looks like in a little bit when we do the practical portion of my section of the workshop, as I'm actually going to be working on an example repository in my enterprise GitHub account. Essentially, it's exactly the same as the standard github.com. It's just more limited. You have to log in with your EID. You can keep the code a bit more private since it's not in this completely public website. You do have the option to have private repositories in GitHub as well, I should say. There have been some concerns about those repositories still being discoverable. So if they were public in the past and then you make them private, I believe there's a way to expose the files or changes that have been made to those files even after you've made it private. So that's something to consider if you decide to go that route. Even if you make it private, it might not be completely undiscoverable. But if you're a faculty and staff member and you just kind of want to play around with GitHub and maybe keep it a little more locked down, the enterprise version might be a good option for you. And you can use GitHub to publish code for your own projects or to contribute to other software projects for which you are a collaborator, or which have been released as open source. So you can go into GitHub and look at issues, for example. I'll just go ahead and show that. If I go to, I'll go to my own GitHub account. So if you go in here, you can see I'm collaborating on a repository right now. You can see people can make comments, push changes, raise issues. If you go to the issues tab here, People can comment, bring up issues with the code, make suggestions, suggest new features, and so on. And it looks like this, and then you can get, pretty vibrant back and forth within the community as well. Okay, so why push research code to GitHub? One big one that I kind of touched on earlier is you can get recognition for the coding work that you've done. Share your work with others so that your code can have a greater impact. Make backups and relatively easily manage the versions of your code. Again, makes it really easy, especially if you have like a breaking change or something, to kind of roll back and go back to an earlier version. Um, you can potentially benefit from others finding bugs and submitting pull requests for code improvements. Um, this has happened on an open source project that I worked on myself, where someone didn't find a bug but made a feature request and put in some sample code. And then I was able to work with this researcher from another university here in the US to kind of work with their code, edit it, make sure it worked well with my code, which is another thing that Git and GitHub can help with as well. So, after I've manually reviewed it, you can run it through GitHub. It'll make sure that everything is compatible with the main branch of your repository, make sure it doesn't conflict with anything or cause any breaking changes. And then if you get the kind of green light from GitHub, you can go ahead and merge those changes and make that public. The enterprise GitHub that I mentioned from UT and the private repositories that I also mentioned also allow for relatively secure and controlled code management. And then you can help make your research workflows reproducible as well. I think one more thing before I go on to the next slide that I didn't touch on before. Um, I think we'll get into it a bit later when we talk about the git ignore feature and hiding certain files from your repository. But you do have to be careful when you're making any code public not to accidentally expose uh, valuable or potentially compromising information. So this could be like passwords, private keys for like an API, something like that, that you really don't want people in the public to have access to, since it could obviously, expose personal data, cause security breaches. If someone gets your API key, they can make a bunch of unauthorized calls to an API and so on. So I think we'll talk a little bit about that later in Michael's portion of the workshop, but something to keep in mind, just because a repository is private or on enterprise, you still do need to be cautious in making sure you're not accidentally uploading anything that should not be exposed on the internet. So some quick terminology, because looking at the time, I don't want to go too long. So Git, we kind of talked about this. It's the open source software used to track and manage versions of files containing text. They have this little logo. That's what I'll be teaching in a second. The repository is the container for all the project's files, can be open or private. So we're going to be creating a local repository, but we'll also be working with a repository online in my section of the workshop. Commit is that individual change to a file or a set of files in a repository. Versioning is tracking and saving records of changes to files over time. A pull request is when someone makes proposed changes to a file or files in a repository that can then be accepted or rejected. So, someone wants to edit the code, maybe they found a bug and they don't have full, administrative access to a repository in GitHub. They can go ahead and make a pull request, explain why they want to change the code, show the example code that they're going to change, and then the owner of that repository can merge that pull request basically and incorporate it into the main branch to allow that pull request to go through. And then a git ignore file, which I just talked about. This just specifies to Git which files in a repository you want to be ignored when uploading to a public, um, like a GitHub repository or something like that. So, you could have a separate file with passwords that you access in your code or an API key that you access in your code. Um, you might want to have this locally on your machine, but of course you don't want that to be available publicly. So you would go ahead and put that in the git ignore file just to make sure that Git does not put that up when you upload your code. All right, so now we can go ahead and start with our sample, our little demo of working with Git in the command line. So you should have your GitHub account already created. Um, so what we're going to do, since you should all have downloaded GitHub Desktop as well, we should have Git installed on our computers. So what we're going to do is create a new repository tracked by Git. After that, we'll make some changes just to kind of see how that works. Then we'll clone a GitHub repository to our local computers. I'm going to go ahead and do that from my enterprise account. You can try to follow along and do this on a GitHub repo of your own choosing, but you don't have to. I have all the example code, so you can always revisit it after the workshop as well if you'd like to just kind of watch what I'm doing and then replicate it later on. Then we're going to edit the repo and we'll push the changes to GitHub using Git. After that, we actually have one more step where I'm going to edit the file in the GitHub web interface, and then we'll pull those changes down to our local repository, just so you can kind of get a sense for how the command line actually interacts with the repositories in this way. So I'm going to go ahead and open our sample code, which I already have in this notebook. So this notebook, this code really should be run from the command line. I just made it available in a Colab notebook for ease of sharing, really easy to put in, text comments and stuff like that. So the code all lives here, but we're actually going to be running it, from our terminals or command prompt if you're on Windows. So the very first thing we'll do is just verify that we have Git installed on our local machine. This command actually does run in Colab. If you put this exclamation point at the beginning, it tells it to run on your local computer. So you see we have Git version 2.34.1. If I go ahead and copy and paste that into my terminal, you'll see I get the Git version that I have on my local machine as well. You can go ahead and do this git config. We don't have too much time, so I might kind of skip over this a little bit, but basically this just configures your name and your email that will be attached to the commits that you make to the repositories that you're working with. So I'll just go ahead and change this really quick. You can see what it looks like. You can put in your name and your email here, put in these. We run that. It doesn't print anything, but you see we got the green check on the side, which means it worked. And then if we show our git config here, it'll print out what we have configured in that previous file, or in that previous code, rather. Okay, so the next part, we're just going to go ahead and create a repository tracked by Git on our local machines. So we're going to use our terminals for this part. Again, don't worry too much about following along. This is really just kind of to walk you through. You can always replicate this later on your own as well. On a Mac, you can find the terminal in your applications, I believe, from your Finder. I have it on my taskbar here, and then I put some quick steps here if you're on a Windows and you're having trouble finding command prompt if you're not familiar with using that. But basically, what we're going to do is just copy these over. These here with the hashtags, if you're not familiar, are comments. So these are just little comments I'm making to explain the code. Those don't need to be pasted or run in the command prompt at all. So this is just making our directory. So if I do make directory sample repo, and then I go to my Finder, did not make it. That's okay. Let's see why that's not updating. It's not see. Oh, I see. So I'm in the wrong workshop folder. No problem. So I'm going to go into my downloads rather to my correct workshop folder. I had multiple workshop folders as I was getting ready for this workshop. There we go. So if I go ahead and run that in the correct folder, I'm in my workshop folder here. Make directory just created the sample repo folder here, which is completely empty because we haven't added anything yet. I already did this, I believe, or no, I didn't. So you can go ahead and do the CD sample repo, which stands for change directory to our sample repository that we just created. And then we can go ahead and run this git init, which we talked about a little bit earlier. This will initialize that new Git repository in this folder. So you'll see we get this initialized empty Git repository in the location that we're in. So we don't have any files yet, but everything in here now is part of a Git repository. So what we're going to do is grab this file that I put up, this readme.md file, go ahead and download that. And then I will go in, copy that into my workshop folder, my sample repo folder rather. Make sure the file name It's the same as what you all are seeing. So an MD file is a markdown file. You'll see this pretty commonly in GitHub repositories, as I have here in the sample one. This is the readme.md file right here. It's basically just kind of generally some general introductory material, talking about the repository, maybe some basic installation instructions, how to use it, and so on. So now that I have that file added to my folder that's being tracked by GitHub. Oh, I see a comment in the chat. Yes, so there will be recordings, so you can follow along at your own pace. I apologize if we have to go a little bit fast, but we do have quite a bit of content to cover. But yes, there will be recordings you can follow along with later. So now that we have that file in our folder, which is being tracked by Git, what we're going to do is make sure that change is tracked. So we added this folder. It used to be empty. Now we're going to commit that file to our repository so that it is kind of updated in Git, basically. So we're going to go ahead and git commit. We are going to do the M flag, which means we're about to send this commit message, and then we put it in quotes. This is a commit. You can put anything there, but typically a commit message will be kind of a brief explanation of what you did, what changes you made, and so on. So if I go ahead and do that, I intentionally did this because I wanted to show that we do have to add the file to be tracked by Git. So you'll see it gives us this untracked files error. What we want to do now is git add, and then we can type in the name of the file that we want to track, sample readme.md. You can, if you want to add, if you add in a lot of files all at once and you want to track all of them, you can do git add and then an asterisk, which I believe adds everything in that repository. You don't have to type in every file individually. But if you only have a couple files, you maybe want to just add them in manually in this way. So now if we do our git commit message, now that we added that file in, you see we have the files changed. The 4 insertions were changed as the lines of the file, and then git track that change for us. So our version control has been initialized and we successfully made changes to the file that have been tracked by Git. Pretty quickly, in the interest of time, I just have a couple more things I want to show. So for this part, I'm going to go ahead and clone my sample repository using that git clone command that I talked about earlier. So this is my sample repository in the enterprise UT Austin GitHub interface. So very similar to the github.com website, but I have SSH set up. So rather than the HTTPS URL to clone, I'm going to go ahead and copy this one over. And if I go to my workshop folder here, I'm going to paste that command in, that git clone, and then I paste the URL from the enterprise repository. I'll be entering my passphrase. There we go. And now that downloaded. So if I go back, now we have this workshop sample repository cloned to our folder here. So you see I have a license and a README. What we're going to do now is make a little change locally to our repository, and then we'll push it, commit that change locally, and then we'll push that change up to the GitHub website. So we'll be able to see how that change is reflected in the remote repository. So this is that README file. I'll just add in a simple extra sentence. Save that to my file. And then if I do this git commit and tell it that all I did was update the README in my commit message. Oh, I got to go into the correct folder here. So I do my CD to the correct folder, and then I run the same command. You'll see it's not tracking that file, so I have to do git add again. Now that file is added. And there we go. So our change is now tracked. It got that other sentence that we added. Now we can do git push, which will push that change to our remote repository on the GitHub website. So I'm going to enter my password again. There we go. It's still running, it looks like. It's writing the objects, and then it uploaded. So now if we go back and I refresh this page, once it loads, we should see our second, there we go. Now we see our second change made to that README file. And that was reflected, in this repository that's hosted online. One thing we can do finally, before I wrap up my portion, is go ahead and edit the file in the browser, which you can do very easily in GitHub as well. So I'll just go ahead and undo that change I made. Commit that change locally by clicking commit changes. Do our commit message here. You'll see GitHub is essentially running the same commands we did in the command line. It's just doing it in the browser. So we're committing just like we did on the command line with a simple commit message, just running it with this graphical interface in our browsers instead. File cannot be edited. This has not happened before. Let's see what happened. It's okay if it doesn't work. But I have not run into this. Oh, there we go. So I edited it. We took that change out. So okay, that was a weird little GitHub glitch. So now that extra sentence we added, that's still in our local repository, right? We only made the change on the website. We undid that change in the shared repository. Let's say we were sharing this with a collaborator. So what I'm going to do is now, this should be git pull. I'm going to run git pull from my command line, and this should grab those changes that we made in the browser and update them in my local repository. So put in my password one more time. And then if I go to the README file, you'll see that sentence we added before was deleted. Our local repository is now up to date with the repository that we have in the browser. And that is the end of my demo. I see some chat messages. Oh, I see.
Yeah, I've responded to a few. I think there's one, Ian, that I haven't had a
Uh-huh.
chance to get to. So I'll leave that one to you, and I'll go ahead and take over from here.
Absolutely.
All right. Okay, so I'm going to pick up where we are leaving off. So thank you, Ian, for walking us through that demo. I have another quick demo that we'll go through to show you how you can use a graphical user interface to manage many of the same tasks that Ian was showing us how to manage using the Git command line tool. So you all hopefully have created a GitHub account by now. And if you could go ahead and log into that account, we're going to walk through a few steps here to show you how to basically do most of the things that Ian was covering using the graphical user interface. So I'm going to hop out of this slideshow in just a second, and we'll do another quick demo. And then we'll come back to the slides to dive a little bit deeper into certain topics about working with GitHub. Okay, so hopefully you also have GitHub Desktop installed. So one of the things that we'll need to do here is to also log in to your GitHub account through your GitHub Desktop instance. So, all right, if you're ready to follow along, I'm going to go ahead and hop out of this. And what we're going to first do is go to our GitHub account. So if you can go to your GitHub account and once you're logged in there, go ahead and pull up a list of your repositories. So if you click on your icon over there and select repositories, once you're here, you're going to see the option to create a new repository, which we're going to go ahead and do for the purpose of this demo. And so in this case, I'm going to choose myself as the owner, and I'm going to say, let's say GitHub example repo. So you can give it any name you like. That's what I'll call it for this particular tutorial. And I'll just say this is an example repository. I'm going to go ahead and make this public. I want to initialize a README file. As Ian was mentioning, that can be helpful. I'm going to add a git ignore file. So many of the projects I work on and many others writing research software on campus might work with is Python. So let's assume this is going to be a repository for Python code. So I'm going to add a git ignore file that is specific to the Python language. And I mean, this is just an example, but in a real scenario, you would probably want to pick a license that defines what others can do with your software that you are developing. So I'm just going to go ahead and pick an MIT license, which is a good, very flexible option that allows others to understand what they can do with the code that you're sharing. So I'm going to go ahead and create repository. And there we go. So this is now publicly available online. People can go to this URL and find this example repository. And now what happens if I actually want to start developing some code and putting it into this repository? I mean, right now it's just these essentially logistical files that are for management of the repository, but there's no actual code in it. So the next step is going to be going to my GitHub desktop installation. So in here, you are going to want to clone a repository. So hopefully you have opened up GitHub desktop. What we're going to do is we're going to clone the new empty repository that we've created down to our machine and have a local copy of that repository. So I'm going to go ahead and select clone repository. And here you might not be logged in yet on your GitHub desktop instance. So you might see something like somewhat like this where there's a sign in button. So you want to click on github.com and then after you select that tab, sign in if you haven't signed in already. And then this is going to show you a list of all the repositories that exist in your account. So if I refresh here and we search, what do I call it, example, here we go. You're going to see it come up in the list, GitHub example repo. There it is. I'm going to want to pick where this is going to save to on my machine. So let me, let's see, I created a folder just for this on my C drive. And that is in GitHub Workshop. So I want to clone it here. So you're going to want to tell GitHub Desktop where to put it on your machine. And I'm going to go ahead and click clone. And this will be really fast because there's not really anything in there. Fantastic. So now if I look back in this folder, we'll see it has been populated with these files that have been pulled from the repository that I created in GitHub.com. Okay, so now if we want to actually put some real code in here, what I could do is open a integrated development environment. So I've got some older integrated development environment called Atom that I regularly use for writing Python code. So in this integrated development environment, you can use VS Code, you can use Pulsar or some other integrated development environment that you might prefer for managing your code. What I've done is I've navigated to the directory where that code is stored. So I could create a new Python file here and say example.py, and I could say print hello world. So now I have a Python file in here. And if I go to GitHub Desktop, we'll see that it is showing me the changes that have been made to that repository. So a new file called example.py has been added, and here's the content of that file. You could also, if you wanted to see a more fully featured Python file that you could publish, you can visit this URL that I'll go ahead and share in the chat. And you'll be able to download a Python script by going to File, Download. So we're going to download this notebook as a Python script. I'm going to go ahead and save it. I'm going to look to the location of this. So there it is on my computer. I'm going to go ahead and cut that out, and I'm going to paste it into our local repository. So now I've added a real Python script here. And if I open this in Atom, we'll see that this is a much more significant Python script. And if we look back at GitHub Desktop, you'll see that now there's two files in here. So here's the file that I've downloaded and moved into the repository. And there's also this example.py file that I created myself. So I could say for my commit message, the title might be added new Python files. Say added a newly created file, a downloaded script. You would be more specific than that in your message. And then I'm going to go ahead and commit to main. So when I do that, that commit has been made locally. That it does not exist yet in my repository. If I go here and we're taking a look at this repository line, I refresh, we don't see those changes yet. Those files are not yet available. If I go back to GitHub Desktop and now I click the push to origin button, this will take just a second. It's pushing those new files up to the remote repository on github.com. And if I refresh that page again, there we go. Those are the files, and it's really that easy. This is usually the workflow I like to take for creating a new repository. I'll create it in github.com first, log in, create the new repository, and then I will clone it locally, just as I did here in this example, and start to create my new files or bring in existing files and build it out that way, and then push those files that I'm contributing to the remote repository on github.com. So that's an example of how you can use a graphical user interface using GitHub Desktop and github.com to manage creation of a repository and committing your code to that repository. So hopefully that helps you understand how you don't necessarily need to use the Git command line tools, although it's a really good thing to be familiar with, right? Some folks might prefer to manage their code that way. Others might like to use an approach like this, where you have that graphical user interface you can rely on. All right, so that demo is wrapped up. Let's go ahead and move on to some slides here. So as you are starting to publish your software projects to a GitHub repository, you are not forced to choose a software license, and you might think that not assigning a license is a good thing, right? That you're not encumbering your code in any way, but it's actually the opposite. If somebody doesn't know how your code is licensed, they could be getting themselves into trouble potentially by using it, right? Because they don't know the terms of use. So if you assign a license, that makes it very clear for anyone that comes across your code on github.com, for instance, to understand how they're allowed to use it and what they might need to do if they want to build on it or use it for certain purposes, like in commercial applications. So it's a really good idea to think through which license you want to assign. There's some very commonly selected licenses: MIT, BSD3, GNU, Apache, and those can have significant repercussions for what you can later do with your code and what others can do with it. So the Open Source Program Office here on campus, which I should have mentioned earlier, this workshop is being co-authored by the UT Libraries and the Open Source Program Office. Our Open Source Program Office has produced a series of best practices documents, including one specifically focused on open source software licenses that you can visit to get some insight into what things you need to consider when selecting a license. And so every project is different. That's not necessarily a one-size-fits-all approach. You'll want to think through which one is best for your particular project. All right, so hopefully you'll find that documentation helpful. All right, so what other things do you need to consider as you are starting to manage your code in GitHub and share it openly? You want to make sure that you're not accidentally sharing more than you should. So it's very common for your software that you might be developing to contain things like passwords or other sensitive data sets, for instance, or also just files that the code is generating, outputs, for instance, that you wouldn't necessarily want to push to a repository, because others running the code will run it with different parameters and they'll get their own set of outputs that they want to see. So it's really important to utilize the git ignore file to make sure that you're not pushing more than you should to your GitHub repository. If you do need to manage passwords and sensitive information, you don't want to hard code that into the files that are being pushed to the repository. One way to avoid doing that is to define secrets in your GitHub account or specifically for the GitHub repository, which I'll go into that in a few minutes for a specific workflow for pushing your code to a Dataverse instance. But that can be really helpful to avoid accidentally pushing a password or something like that to GitHub. And once it's pushed there, keep in mind, that everything that you put on GitHub is versioned, right? So even though you might very quickly overwrite what you had pushed, that doesn't necessarily remove it from the record of all the changes that you've made to your project over time. So you want to be really careful with that. We've already talked a little bit about the README file and its purpose, right? To give your potential users of your software an idea of what the software does and how they can make use of it. So I'm going to touch on a few points here that I think will be helpful as you consider what should go into that README file. You can tell potential users of your software, what does your project do, right? Why might they find it useful? How does it work? How can they use your code? Again, if there's any limitations or restrictions on what it can be used for, both technical or things associated with the license, you want to let others know how they can actually get started using it and what steps they might need to go through to set it up on their system. Let them know who maintains the project. This is an opportunity for you to let everyone know that this is something you've developed, and also provide contact information or instructions for how they can contact you if they have questions. And again, it kind of ties hand in hand here with this last point of how can others get help, right? Usually those that maintain the project will have the ability to provide some support for that. So you want to let them know where they can turn if they have questions, or if there's other more detailed documentation, perhaps at an external website they can visit to learn more about your project and how to utilize it successfully. Once you get really involved with managing code in GitHub, you might find yourself in a situation where you want to try something new out with your project, but you don't really know how that's going to turn out. You want to build a new feature into a piece of software that you have shared through GitHub. One of the great things about using Git to manage your code is you can create what are called new branches to essentially create a working copy of your code base where you can test things out, make changes, and if things go well, you can push it back to the main branch. And so it's a way to split your project up to facilitate collaboration with others, or to manage development of new features that you might be working on, even if you're working independently. You can also fork an existing open source repository. So this might be helpful in situations where you see a really cool project that you find on GitHub and you want to take it in a new direction, right? And customize it pretty heavily and do your own thing with it. Well, you can create what's called a fork there in order to be able to do that. So you can copy that code down locally and clone it and fork it so that you can then start to build on it. Again, pay careful attention to the license associated with that project, though, because that might impact what you can do with a fork of the software down the road. And let's say you create a fork and then you realize, wow, you've made some really interesting contributions to the project. You actually want to bring those to the attention of the original developer or maintainers of the project. You can submit a pull request in that instance to basically propose a change to the main code base and allow them to bring that fork back in and include your contributions if they're willing to accept those. I also want to touch briefly here on GitHub Actions. So GitHub Actions are a way to manage continuous integration and continuous deployment. So anything related to building of software, automated testing of it, automated deployment to certain systems. This functionality is free for public repositories. So if you're openly sharing your work on GitHub, you can make use of GitHub Actions. And there's just many different ways that you can utilize these automated processes. They can be run manually so that you can set off a workflow where something happens to your code, or you can have them run when a certain event takes place. So let's say a new release of your software is made. Maybe you want that to trigger certain steps that run automatically. And you can also run it at periodic intervals. Maybe every month you want something to happen, or every week. You can create a GitHub action to manage that. One way that GitHub Action can be useful is if you want to automate pushing of your code to a repository where it can be preserved and where it can receive a DOI. So in GitHub, you can create a citations file that helps people understand how they should cite your software, but one of the ways that we can also more effectively allow others to cite our work and ensure continuing access to it into the future is to assign a persistent identifier to it. So that might be a digital object identifier, or DOI, right? Something you might be familiar with from publishing a research article or publishing a data set. We can also get a DOI for our software if we put our software in an appropriate repository that assigns DOIs. So one such repository you could choose to utilize is the Texas Data Repository. So the Texas Data Repository is our institutional data repository here for the UT Austin community. And it is one that is frequently utilized by our researchers here to preserve and provide access to their research data that might be associated with a publication. So let's say you're working on a project, you have a lot of digital data that you've collected, and you're using Python or R to run your analysis on that collected data and come up with your results that you're then publishing in a journal article. If you want your work to be fully reproducible, many researchers are familiar with the practice of publishing the research data to a repository so that others have the chance to review it, and also to perhaps make use of it in future studies. Going one step further than that, you could also make sure that your software is not only shared in GitHub, but it's actually preserved and also gets a DOI. And so you could push your code to GitHub, and then have it preserved automatically in the Texas Data Repository alongside your data sets that are associated with their publication. So what's really nice about this automated workflow, using a GitHub action, you can have it so that every time you push a new commit to your GitHub repository in GitHub, it will automatically trigger an action that deposits the latest version of your code in a specific data set in the Texas Data Repository. So this is an overview of how that process works. You can visit this link down here at the bottom of this slide to get really detailed information about how to set this up for yourself. But let's say in this example I mentioned earlier, you've collected some data, you have an R script, let's say, that analyzes the data. You want to share both the R script and the data itself on the Texas Data Repository. What you would do is you would create a new data set in the Texas Data Repository for your data. You'd create a separate data set in the Texas Data Repository to hold your software. Once you create a draft version of that data set will receive a DOI. So you can see an example of that over here on the right. There's a DOI for a project I created yesterday. And then you will also need to generate a Dataverse token. So it's really easy to do once you're logged into the Texas Data Repository, which runs on Dataverse software. You would look up in the top right under your account information, and there's an API option in the menu there. You'd select that and you'll get a Dataverse token. You want to take that token, you don't want to hard code it into the YAML file that defines this process. You want to use the GitHub secret function. You'd log into your account, you'd navigate down to secrets and variables, you would create a new repository secret for the repository where your code is managed, and you would call it Dataverse token, and you would put in your unique token string there. You would then create a new folder within your GitHub repository called .github. You would create a subdirectory in that called workflows, and you'd create a new file in there called workflow.yml or YAML. So it's a type of configuration file. That YAML file will look like what we see here. So it defines when this action should be triggered. So on a push to your GitHub repository, that's what push is doing here. And what's going to happen is it's going to run this process under jobs. So it's going to use the Dataverse uploader GitHub action that's defined here. And these are the key parameters that are defined for this. So it needs to have your Dataverse token in order to access the data set you've created to push your code there. You need to define the Dataverse server. So this is the Dataverse server for the Texas Data Repository, dataverse.tdl.org. And then you also need to define the DOI for your data set, so it knows which data set to put the code into. And then by default, it will delete any existing contents in that data set that you've created in TDR. You don't want that to happen and have everything essentially overwritten. You can say delete false, and it will not remove anything that was in there previously and completely replace it with the contents of your GitHub repository. So that's optional. There are some other optional parameters as well, which are defined when you visit the page that we have linked to at the bottom of the slide. So that's just one way that you can get a digital object identifier for your software and ensure that it will be preserved in case anything ever happens to GitHub, right? It is owned by Microsoft, which is a company that might make different business decisions down the road. They can make decisions that might impact availability of your software. If you want to ensure that it will continue to be available, or if you want to publish it alongside a data set to help facilitate reuse of your research products that you are creating, it's never a bad idea to push your research software to appropriate repository. So we've already talked about how to do that for the Texas data repository. The other options you might want to consider are Zenodo. So this is one that GitHub recommends. They have a documents page that describes how you can utilize Zenodo to get a DOI for your software as well. And there are some others that I won't go into detail about here, but if you're working with R or you're doing anything that's AI or machine learning specific, you might want to consider these other options. But Texas Data Repository or Zenodo are two to maybe look at first. If you are interested in using Zenodo, the process is quite a bit different than it would be to preserve access to your code in the Texas Data Repository. It's perhaps a simpler process. Some might consider it to be simpler. These are the instructions here. You can see it's really a few easy steps. You would need to create a Zenodo account to do this. You'd sign in with your GitHub. You'd allow access to your GitHub through Zenodo. And then there's just a few more steps to make those sync. I do want to mention that being introduced to Git and GitHub and trying to figure out some of the complexities associated with license management and getting a DOI for your software, it can be a little bit daunting, perhaps, if it's the first time that you're going through some of these processes. And I do want to emphasize that the Open Source Program Office here on campus is here to help. So the Open Source Program Office was established in the summer of last year in 2023, and in the last year, we have been busy building out services and resources to help members of the campus community engage with and develop open source software. This is a partnership between the Texas Advanced Computing Center, Information Technology Services, the iSchool, and the UT Library. So we're bringing together folks from all of these teams to really build out the resources that this Open Source Program Office provides. And our goal is to really support folks throughout the process of getting more comfortable using and engaging with open source software. So you might start out as a user of an open source tool. We want to help you get to the process where you feel comfortable contributing maybe to an existing software project, openly sharing your own software projects that you might be developing from scratch to support your research, getting things to the stage where you can comfortably accept contributions from others who might be starting to utilize the code that you've published, and even getting to the more advanced stage where your project is self-sustaining. It has a large number of contributors who are working together to move that project forward. So we want to help researchers at all stages of working with open source software. In order to do that, we are planning trainings and events, including trainings like this workshop here. We can help with identification of funding opportunities related to open source software. We have best practices guides, which I've already mentioned, that are published to our website at opensource.utexas.edu. We can also provide consultation services. So if you have a particularly tricky question and you're looking for personalized support, you want somebody to talk to get some advice, we'd be glad to meet with you. And here's how you can get in contact with us. You can contact us at OSPO at utlist.utexas.edu. You can visit our website, opensource.utexas.edu, or use that QR code right there. We have a mailing list where you can receive information about upcoming events or new resources that we've developed. You can also book a consultation with us using our new consultation form at this bit.ly link here. Again, these slides will be posted to the Data and Donuts LibGuide shortly after the workshop. So you'll have access to all these links as soon as we wrap up here. That is a quick introduction to the Open Source Program Office, which again can provide help if you have any questions about how to make use of GitHub for your research. And I'll turn it over to Ian to highlight our Scantext Studio.
Yeah, I just wanted to quickly highlight, I'll put a link to the guide with more information about the space in the chat as well. I just wanted to quickly highlight the Scantext Studio. It's a physical space that's part of our Scholars Lab in PCL in our main library. We have a lot of material, a lot of web software pre-installed on the machines here, some great, really high quality scanners. If you're thinking of working on a digital project that involves digitizing text using optical character recognition on the text, natural language processing, anything like that, I'd recommend checking out the space. It's a great opportunity to use the space to kind of further your project. So just wanted to plug that room here really quick.
Yeah, I will also share, as I've already mentioned, you can reach out and get in contact with the open source program office anytime. We also do have some opportunities that are available for those that might be interested in engaging further with the libraries and open source program office. We do have a UT GIS Day poster competition coming up on GIS Day, which will be Wednesday, November 20th. And so this will be an event held in the PCL Scholars Lab on campus. And also we'll be streaming many of those events on Zoom too. We're not able to attend in person, but we are going to have an in-person poster session. If you're interested in presenting any work you're doing with GIS or other geospatial technologies, including open source GIS or open source scripted processes you might be using to manage geospatial data. We'd love to see your poster included in our event. Proposals are due Tuesday, November 5th. You can visit the UTGIS Day website here at this link in order to see more information about that. And if you think that there are opportunities for you to include map and geospatial materials from the UT Libraries collections in your research, I do want to mention that we have a Map and Geospatial Collections Explorer Fellowship that we offer annually, and the deadline for submitting proposals is this Monday, October 14th, by 11:59 p.m. So if you've got any ideas there, you're already working on something geospatially related, you have an idea for a geospatial project where you think you can utilize materials from our collections, consider submitting a proposal. And with that, I think we can go ahead and wrap up here, and we still have quite a bit of time for questions if there are any. And I'll also just mention too that again, our last workshop of the semester is coming up on October 25th. We want to learn a little bit more about creating open source research software. This will be a good introduction to R for data management. All right, so if there are any questions, feel free to raise your hand. We can let you unmute if that would be easier. You can also post any questions you have in the chat. We'd be glad to answer them. All right, well, we can give it another few minutes, but hopefully, after this session, you feel a little more comfortable with the idea of using GitHub to manage research code that you might be developing or working with. And yeah, it can be a really helpful tool. It takes a little bit of getting used to get fully comfortable with it. But once you start using it more, it becomes somewhat second nature. So yeah, hopefully this is going to be helpful to all of you. And again, I will just reiterate that our slides will be posted to our Data and Donuts LibGuide site, which we've shared there in the chat, and the recording will also be accessible a little bit later this afternoon. If you want to rewatch it, go through things a little bit slower, or see it all again, you might find that helpful. All right, so we have a question here. Can you explain how the GitHub repositories work with already established R projects? It is just as simple as uploading, or do we need some type of integration? So are you thinking of an R project that you've already been working on that you might now want to start sharing through GitHub? Or are you referring to like established R projects that somebody else has created and is managing on GitHub? Okay, great. So clarification here. One that they've been working on and want to share with collaborators. So a good example, I think, perhaps, is if you have not yet been sharing this, you've been developing it locally, it's something that you've only been contributing to yourself. You can follow the steps in the demo that I walk through pretty closely, I think, in that scenario. So you could go into your GitHub account, create a new repository that you would be setting up for that particular project, and give it a name, create a README file, decide on a license for it, and then it would be an empty repository, github.com. You would, again, I'm going to talk about how you could use GitHub Desktop, but you could also use Git to do this too in the next step. But you could go to GitHub Desktop where you've connected to your GitHub account. You could clone that new empty repository down locally, so you now have a local copy of it, and then you could take your existing R files and copy them into the empty repository, and then push that code to your repository on GitHub. So that would be one way that I think you could create a new repository and take your existing files and code and push that to the new repository in GitHub. Does that answer the question? All right, great. Yeah, it can be a little bit tricky to figure out how best to manage that when you're just starting out. So, and that's a workflow I've utilized myself for projects that, I might have started years ago and didn't necessarily originally have the intention of those being things that would be shared. But, sometimes things develop in directions you don't necessarily imagine at the start, and you want to share something out, months or years later. That is a good way to approach it. And so you would have a very large initial commit, right? You might have months or weeks or years of work all of a sudden that's being pushed out all at once. But moving forward from that point, the changes that you make, right, you can version them and have that commit history that's really helpful to see how that project develops over time. And of course, to make that code available to others that you might want to collaborate with. Any other questions? All right, great. I see a hand has gone up, so I'm going to go ahead and unmute you in case that's how you'd prefer to ask. All right, so you should be in.
Hello, can you hear me?
Yes.
All right, thanks for this presentation. Bringing all that material together is really useful. My name is Antonio. I just have a quick question regarding how you manage your GitHub when you have, let's say, thousands of repos, and I want to kind of categorize them. Like, I wish I could have like one folder. Let's say I have 5 projects that belong to one specific folder, and I don't want to have like 125 repos. Instead, I want to have like 4 folders, and then the first folder belongs to, I don't know, X amount of projects. Let's say I'm studying, I don't know, data science and natural language processing. I have 4 projects, and then in deep learning, I have 5 projects. So I wish I could have only. Is that possible, or that's the wrong way of put the hierarchy in order in your GitHub?
Yeah, that's a good question. So, and I don't know who between the two of us has more GitHub projects. I don't know that I've gotten to the stage where I've needed to try and group related projects together. I'm curious if that's something you've run into.
Yeah, I think I have about 60 projects on mine, so not near the level it sounds like you're thinking about. My projects I tend to keep separate if they are very self-contained and they kind of make sense as a discrete entity. I think a lot of it might depend on the size of your projects and the scope, and how well they might work together. I have seen people create sort of group repositories before, though, where they kind of have a central place where they could have all of their natural language processing code, for example, live. So it's not, unheard of if that's what works best for you. But I think you would have to kind of look at each project or each grouping of projects kind of on an individual level just to see what makes sense to you. Like if it feels like those all work well together and it makes sense to put them in one repo, I certainly think it would be appropriate, especially if you have a lot of, smaller projects that would go well together. So I don't think it would be incorrect to do that. Um, but in from what you've described, it sounds like it would be something that maybe you'd have to kind of assess based on each project and kind of what you're hoping to accomplish as well, because those projects might not be as visible, if they're all grouped in subfolders and things on GitHub. If you're trying to get, a lot of public visibility and have them available in search functions and things like that to maybe get collaborators, that would be, one downside to having them all kind of nested and grouped together as well.
Yeah, that's true when you say thank you. I tried to do that before, and one of the disadvantages is when you want to clone, you will clone folders that you don't probably need, and that will, you know, bring more stuff that you don't need anymore. But thanks.
Yeah, of course. Yeah, thank you. Yeah, that's a great point too. Yeah, cloning or editing, you have to get everything in that repository at the same time. Yeah, that's a great point to bring up.
Any other questions? All right. Well, I don't see any other hands going up or other comments or questions showing up in the chat. So I think we might be able to wrap up here. Ian and I have our contact information here. Please feel free to reach out to us if you have any questions about anything we've covered in the workshop today. Again, if you have any general questions about open source software and how you can get support here on campus, you can feel free to reach out to me. I am a co-PI for the Open Source Program Office, or you can refer to the Connect details that I shared a little bit earlier in one of our slides for how you can get in contact with the Open Source Program Office. We are here to help, and always glad to be of assistance for those that are engaging and working with and sharing open source software. All right, thanks for attending today. Hope to see you at our next workshop.
Thank you all.